All right, today we are going to start taking a look at linear equations. We've looked at solving equations. We spent a couple of days in class. Thanks, ladies. We spent a couple of days in class working in groups on solving equations. And by and large, they were linear equations we were solving at that point. So we're shifting our focus today a little bit, but we are still focusing on linear equations. Today we're going to take a look at a couple of things related to linear equations. The first one is slope. So if you'll remember, slope is a number that describes both the direction and the steepness of a line. When it references direction, it has to do with whether it's measuring it positive or negative. Positive means that it's increasing, negative that it's decreasing. And when it references steepness, if the value is large, well, we'll say it this way. We'll say that larger means steeper. So when you're comparing two numbers, if a number is larger, then it's a steeper slope. All right, and if it was a smaller value, it would be the shallower or the flatter of a slope. I've put down several varieties of the ways that we describe and talk about slope. Rise over run is a very visual description. We're going to look at that one first. Change in y over change in x is kind of an intuitive sort of a description. The delta y over delta x actually means change in y over change in x, but it's more condensed. And then y2 minus y1 over x2 minus x1, whoops, I was trying to erase that, is more of a formula kind of a perspective, having something that you can plug numbers into. Okay, nod your head if you remember working with slope in the past. I got everybody nodding? Good. So this is not new material. It may be material you haven't seen in a really long time, though. So we might need a refresher, okay? So does everybody have everything on this slide? Not quite yet. Okay, we'll pause. Okay, we're good? All right, so we're going to do some examples, and they come at us from some different perspectives. The first one is the slope of a line, and it says of the line graphed, and I'm going to actually draw it on here for us. It will be given to you in your homework when you do that. It has a couple of locations noted on your graph. This is the first one. That's at -4, -1 as an ordered pair, if you want to think about it that way, and all of your book will have, your questions will have them noted that way. And the other one is 4, -5 over here. So you will receive questions that are already drawn in like this. Okay? So this is the graphed line. I'd like for you to take a perspective on this one from that rise over run idea. Okay? So it's not the only way to do it, obviously. I just gave you like 4 different descriptions of how we could calculate slope. So rise means how far it goes up, and this one actually doesn't go up, it goes down. How far does it go down until we get to the next point? What is the decrease from here to here? It goes down 4, right? The first place it's at a height of -1, and then the second location here it's at a height of -5. So it goes down 4. So when we're thinking of it as rise over run on this one, the rise would actually be a -4 because it went down, okay? How much did it run? That is to say, how long, what's the distance, that it goes from left to right to get from the -4, -1 point to the 4, -5 point? What's the distance? Here to here. Yep, from -4 to +4 is a distance of 8. Right? So it runs, if you will, 8. That's the horizontal change. What would -4 divided by 8 be then? Yeah, it's -1/2. So we would reduce that. I'm going to do another one here in a moment where I actually use the formula. You could use the formula on this, right? You could use this perspective at the end if you didn't like the visual graphical sort of anticipation that I was sort of describing, right? You could do that. All right, so let's take a look at another one then where we actually have no graph given and we only have ordered pairs given. Here we're asked to find the slope of a line that passes through a couple of different points. The points are -9, -3, and 7, -7. Now it doesn't really matter how you label as long as you're labeling in pairs. So if I decide that -9 is x1, then that means that -3 is y1. And then that means that the other pair is x2, y2. And that's just me going in order from left to right. If you switch them and you call the first pair x2, y2 and the second pair x1, y1, you will get the same answer. It won't make any difference. Okay? So you pick each of those points and label it. So the formula perspective says I'm supposed to do y2 minus y1 over x2 minus x1. So what is y2 from the way that we've set this up? It's -7, right? Yeah, -7 minus, and what is y1? -3. So minus a -3. Careful with the shines. And then I need to divide by x2. What is x2? That's actually 7. I won't circle it again because I've got so many circles going on. And what about x1? -9. So I need minus a -9. So what happens when I have that minus a negative? We've talked about integers this semester. Yeah, it makes positives, right? So this actually ends up giving me -7 plus 3, which would be what? -4. And in the denominator I have 7 plus 9, 16. And how will -4 divided by 16 reduce? Yeah, -1/4. Okay, so I know both of those ended up being fractions. Slopes are not always in fractional form. We certainly could end up with a whole number. They both also happen to be negative, and of course, slopes are not always negative, okay? So any of those kinds of things can happen. Let's try another one here. This one has the points -5, -1, and -5, 4. So here's x1, y1, and x2, y2. So if I'm creating my slope on this one, slope, I didn't define it, I'll define it later, but slope often also has the label m, if you want to call it that, somewhere along here. If you don't, it's fine, but if you see me doing it, that's what I'm referencing, slope is m. All right, so I need y2, what is y2? 4 minus y1, which is what? -1 over x2, which is -5 minus x1, which is -5 as well, right? Yeah. So what do we get on top? 5, and on bottom? 0. What is 5 divided by 0? Nope. Nope. Undefined. It is undefined. We've talked about this briefly, but not from this perspective. You can't divide by 0, and I'd like to show you really quickly why that's an undefined operation. 5 times what equals 10? 2. And because that's the case, we actually also know that 10, I'll actually write it over here. 10 divided by 2 equals 5, right? Those go together. You call them a fact family when you're first learning them, okay? So let's say, for instance, now that we start down here, and I start with that 0. 10 divided by 0, right? Because I just had 5 divided by 0, but let's say we have a number divided by 0. Well, what has to be true if there is an answer to it, like you guys are trying to give me answers of 0 or other things, is that there has to be some number that I can multiply 0 by and get back to 10. And there's just not, right? Yeah, there just isn't. 0 times anything will not give me back 10. It's an undefined operation. Okay? So we're not going to divide by 0. Doesn't work. What if I had 0 on top? What if it actually had given me the result of 0 over 5 instead? That would be 0. Okay, so zeros in numerators, totally cool. Zeros in the denominators are undefined. Okay? All right, one more of this variety in terms of our slope idea. We did graphing in our second unit back in the intermediate algebra portion, and we did it by plotting points, right? We plotted 2 points when we graphed lines because 2 points were enough. Well, in this perspective, I'm not given 2 points. I'm only given 1 point, and I'm given the slope. I've created the problem to mirror what your homework says, but I absolutely hate that it does this. It tells you the y-intercept is -6, and they really should write down that the y-intercept is 0, -6, because the y-intercept is an ordered pair. Okay, so I did it in my notes just so it would mirror your questions in your homework. So we're going to start by plotting the 1 point that we know, 0, -6. So that would be down here. The next information that we are given is the slope. Is this slope positive or negative? It's positive. So will the graph be increasing or decreasing? It will be increasing. And we always read graphs from left to right, just like we read our English, printed text, left to right, okay? So we are going to be increasing from left to right, which means the ordered pair where I'm currently at, if I move to the right, am I going to go higher or lower? Moving to the right, higher. Yeah, so I need to go uphill like this, right? I didn't draw anything yet, really, just direction. And the direction I'm going is going to be a direction of 2. So this is not a fraction, at least it doesn't look like one right now. But it's equivalent to writing 2 over 1, right? Yeah. So what this means, again, in terms of a graphical perspective, is that I'm rising 2, and I'm running to the right 1. So on my graph, if I rise 2 from -6, if I go from -6 and I go up 2, where will I be? At -4, right, on the y-axis. And then I'm going to go over 1 to the right, will put me right here. So the location where I am now, that new point, is what? Yeah, it's 1, -4. You don't necessarily have to label it. I'm just making sure we're all drawing the same thing. And again, just like we did when we were doing ordered pairs before and just plotting pairs of points, once I have 2 points uniquely determine a line. If you want to draw more points in, just keep going up 2 over 1, up 2 over 1, you can, but 2 points is enough. And once I have those 2 points, I can connect them. That was not a good one. That was better. I can connect them with a line, and I put my arrows on the end. Okay, so I don't always have to have 2 points to plot a line. If I have the slope and a point, that works as well. Now, in particular, it would be nice if we could always look at something and know the slope and the point, because, that was enough information to graph the equation. And we can. We have a form of an equation called a slope-intercept form. So slope-intercept form is one form of a line where the slope and the y-intercept values are readily visible. You can see them. That's what that means. You can see them. The form looks like y equal mx plus b. M is the slope, and 0b is the y-intercept. Now, chances are pretty good that if I asked you, what's an equation of a line? This is the one you remember, right? Most people do. It's pretty common. What's the equation of a line? It's y equal mx plus b. This is one we use a lot. One of the reasons we tend to like it is because your calculators you guys have sitting around everywhere are set up to take input like that, right? If you can get it to say y equals, then you can graph the equation whatever comes next. So that's one of the reasons that we like it. For lines, one of the reasons we like it is exactly what this description tells us, is because it's easy to see the slope and the y-intercept. The reality is, some lines already have that form when we're given them, and some do not, right? Okay, does everybody have everything written at this point on this slide? Okay, so number 5 says y equals negative 5x minus 8. Is it in the y equal mx plus b form? Yes, it is. Good. So let's just identify what the slope, the question asks us to find the slope and the y-intercept. So in this form, what is the slope of this line? It is negative 5. You got it. Now the y-intercept, even though your papers are going to give you single values when they ask you questions like I did over on this one, right? They're just going to say negative 6. You're going to write it as an ordered pair because that's mathematically correct. So what is the slope, what is the y-intercept of this equation? Very good. You guys said it right. Good. So it's 0, negative 8. It's not just negative 8. Okay? 0, negative 8. Looking at 6. Is it in y equal mx plus b form? Got yeses and nos. It's actually not, but it's pretty close, right? Like I could plug it in the calculator, but it's really not quite in the right form. If you're comfortable looking at it from there and identifying it, you can. If it bothers you to see it that way, all you would need to do to put it into that form is to switch the order of what's on the right side. So if I simply move the negative 5 over 4x to the front and the positive 6 to the end, that's actually the right form that we're talking about. Do you have to do it that way? You don't have to, but sometimes it's easier to see. So what then is the slope for this equation? Good, it's negative 5 over 4. And what is our y-intercept? 0, 6. Okay, so it wasn't quite in slope-intercept form, but it was close. How about this one? Is it in y-intercept form? No, and it's not even close, right? This actually has a name for the form. It's called standard form of line. We're not going to use it extensively, but standard form of a line means you have integer numbers, okay? And the first coefficient is x, and then it's y. The constant's on the right. The constant at the beginning is positive. Those are descriptions of standard form. But it's really hard looking at this to determine the slope and the y-intercept without doing a little bit of moving stuff around. Agreed? The other one was easy. I don't necessarily have to move things. If I see it, I could leave it and we'd be good to go. You're not really in that same boat here. Got to move some stuff around. So, what would you like to move first? The 3x. And we can do that with subtraction, right? So I have 8y on the left. And in y equal mx plus b form, the x part comes first and then the constant second. So I might as well write it that way at this point now and get it in that order. So negative 3x and then minus 2. What would I do next? Divide by 8. And I find it easier to divide each term by 8 because we're going to be identifying pieces of things later instead of looking at it as a big old giant fraction. So we have negative 3 over 8 x, and then minus 2 over 8. Okay, good job. What is the slope? Yeah, negative 3/8. What is our y-intercept? 0 and negative 2/8. Anything we could simplify? Yeah. On this one, over here, let me go back a step and we'll simplify. So this is negative 3 over 8x minus 1/4. And we will adjust it over here as well. Negative 1/4. All right, so with that same idea, we've got another equation given to us. It's not quite in standard form. It's got a negative at the beginning. That actually means it's not in standard form. And we're asked the initial question that's the same as the ones we were just dealing with, to find the slope and the y-intercept, which we know how to do. We need to get it in different form. And the second question we're asked is to use that slope and that y-intercept to graph the line. We already did that too, right? So this is like a combo problem. It's a 2-for-1. So we need to first change this negative 2x minus 8y equals 24 into slope-intercept form. So I'd like for you to try to do that. Check with a neighbor when you get to your stopping spot. Once you get down to y equals, don't go graphing until you've checked. Check in with a neighbor. Do you have the same y equals form? Cheers. Check in with somebody nearby you. I see lots of people getting finished with that part. Okay, so I think I have y equals negative 1/4 x minus 3. Is that what you guys have? Fabulous. So what then did you decide that your slope was? Yep, slope is negative 1/4. And your y-intercept? Yep, 0, positive or negative? Negative 3, good. 0, negative 3. Okay, so use that information then to plot it on the graph. Okay, I know you're drawing your own graph, but use it to plot things on a graph. Where would you start? The y-intercept, which it says is at 0, negative 3, so that would be right here, yeah? This slope's different than the slope we did before when we did one of these. It's negative, which means it's going to go down, right? And I'm going to go, actually, you're not quite there. It is going to go down, but it's still going to go right. If we go down and left, we will end up with an increasing graph. We need a decreasing graph. So we're going to go down 1, because it says 1/4, and we're going to go right 4. So down 1 and right 4 puts me right here at 4, negative 4. Again, you don't have to label the 4, negative 4 necessarily, but just to make sure we're on the same page. Okay, what are we going to do next? Draw a line. Okay.
Where do you get that for?
Counting is all I did, actually. So when I went down 1, I was already at -3, so now I'm at -4. And I go right 4, I'm at the 4 on the x-axis. So that's what I did, yeah. Good question. Let me see if I can move that. Yeah, that's not working. Hey, look, there we go. All right, there's 4, -4 from that point. Okay, arrows on the end, please. And we're good to go. Any questions on that one? Okay, it's just a 2-part problem, much like the earlier ones that had single parts to them. All right, we're going to shift gears and go the other direction now. Not so graphical, more of an algebraic, numerical kind of input perspective. Here we're given some information and we're asked to create the equation for the line. It says to write an equation in slope-intercept form for the line with, and again, because your book did it, not your book, but your homework does it, I'm going to use their y-intercept is 7, it should say 0, 7. And it's a slope of -1/3. Okay, so our standard form, not standard, our y-intercept form is y = mx plus b. Where am I going to put the 7? Yep, in the b spot, right? That's okay. And where am I going to put the -1/3? That's where the m is. So my equation ends up looking like what? Very good. So if you have this question on your homework, how long is it going to take you to do that problem? 0.3 seconds. That's really fast. Wow, fantastic. So I could assign a whole bunch of problems then, right, Sarah?
No.
Oh, Preston. What? What? Okay. Now 10 is different, and I'm going to show you something that you might not ever have seen before. I haven't gotten to show you a whole lot you haven't seen ever. Okay? So I've only shown you one type of line, y = mx plus b, right? That's all I've shown you. And there are other versions, and we'll get to them later. But I want to just stick with that one version because the reality is it's sufficient. You don't need anything else. All right? So we are given a point, -9, and that is not the y-intercept, is it? How do you know? It's not 0, 7, right? It's not the y-intercept. And we are given the slope 2/3. So in terms of the y = mx plus b form, I don't know b with that information right now. Agreed? Yeah, I don't. So what I do know is that I have y = 2/3 x plus b. That's what I know so far. That's the 0.3 second part, right, Sarah?
Yes.
Yeah, okay, good. But I gotta know what b is. Now, it's been a couple of weeks ago. A couple of weeks ago, we were finding ordered pairs that worked inside of lines, right? And all you had to do is you had to find one x value and then you plugged it in and you could find the y value corresponding, right? And that's how we were plotting graphs. Is everybody with me? Yeah, so if there's a point on our graph, it has to work in the line. Well, that's true here as well, which means the point that I'm given is a solution of this line. It is a point on our line. It means that it actually works in the x and the y location on this line. And I can use that to figure out what the b value should be. So the long and short of it really is that this -9 can be substituted in for x. And this -7 can be substituted in for y, and I can find out what b is. Are you with me? So let's try that. I've got -7 in for y. I've got -9 in for x. And I'm looking for b. Looking for b. You guys getting a sense of why we work so much with fractions early on? Yeah, they keep coming up, right? Okay, so I've got 2/3 of -9. How much is that? It's -6, right? So this 9 and the 3 reduce to 3. 3 times 2 is 6, and I've got the negative from the 9. This is a -6 plus b. What's b? It's -1. If you need to see it, you can actually add the 6 to both sides as a further step. But the b value is, in fact, -1. Am I done? No. Why am I not done? Yeah, I found the piece of information I needed, but I haven't actually answered the question asked, right? Yeah. So we need to make sure that we're answering what was asked. We're asked to find the equation of a line. But now I can do that. I've got y equals that same 2/3 x, and I just found out my b value is -1. Was not 0.3 seconds, right, to do that problem. Took a little bit longer. Common mistake, super common mistake, is to get to this point and to stop because you feel like you've done a lot of work at this point. So please don't stop short, okay? Make sure you complete to the end. Okay, let's try, we have a few more here. I have another one where I've got a graph to draw in for you. So this one is going to be through this graphed line. My line actually crosses at -2 and at 8 for my x and the y-intercepts. Okay, so it's right here at -2 on the y-axis, and it's at 8 on the x-axis. Okay. Well, I need a slope and a y-intercept. Do I have one of those things? I have one of them. I have a y-intercept. What's my y-intercept, Megan?
0, -2.
Yeah, 0, -2. I know b, right? Okay, the graph tells me b, so I get one sort of, visually for free. b is -2. But I need to find m. Well, good news for us, we've already done that, right? We know how to find m. We have several ways to find m. How would you like to find m? You want to count, Sarah? Sarah wants to count. Okay, so if you count, you would count up from the 2 points we've got listed, right? Those are the ones I'm going to use. We would count up how many? 2, and we would come over how many? 8. So my rise over my run would be 2 over 8. And I am going from left to right up, so it is positive. And what is 2 over 8 reduced to? 1/4. Am I done? I got to put it in the form, right? So y equals what? 1/4 x minus 2, yeah. Plus a -2 if you'd like. You can say plus -2. It's a good catch. Okay, so that was kind of nice because I could see it visually, like I could count on the graph, and that's kind of cool. But what if I have an ordered pair, or a pair of ordered pairs, and neither one of them have a graph to go with it, right? And they don't have lots of zeros involved. Like those were x-intercepts and y-intercepts, which is so nice because one of them is 0. But this one isn't. It says we're passing through the point -2, -5, and 4, 5. I don't have a slope or a y-intercept here, right? Does everybody notice that? Keely, what do you have an idea of?
y2 minus y.
Awesome. Okay, so we'll first find our slope. y2 minus y1 over x2 minus x1. And we'll label them the way we did before, x1, y1, x2, y2. So what's my y2?
5 minus -5.
Okay, good. 5 minus -5 on top, and on bottom? 4 minus -2. So what do I get on top? 10, and on bottom? Not 8, but good try. 6 will work. And how will that reduce? By 2. So I've got 5/3, right? 5/3. We're about halfway there. That's the slope. What do I still need? The y-intercept. So, y equals mx plus b, right? I know m. It's 5 over 3. What else do I know? I know 2 x's and 2 y's actually, right? just need to pick one. And if I pick a different one than you do, we're still going to get the same b. How cool is that? It's pretty cool, right? So let's find, how about we use this one since it's positives. Are you good with that? 4 and 5, they're positive? Okay, so 5 for y, 4 for x, plus b. We're going to end up with fractions sticking with us this time. They don't reduce, unfortunately. You guys are big kids. I know you can handle it. All right, so what is 4 times 5 thirds? 20 thirds. How will I solve for b? Ooh. Subtract 20 thirds from 5. Oops. Oh, that's a messy one, isn't it? It certainly is. Okay, common denominators, yes. Hang on, I need some more space, just a second. That didn't do it. Okay, so the 5, if I write it as needing a denominator of 3, what would I have to be multiplying it by? Like it would be 3 over 3. What would I get? 15 thirds minus the 20 thirds that are there, right? What's 15 thirds minus 20 thirds? That would be negative 5 thirds. So my b value is actually negative 5 thirds. How did I end up with 15? I need a common denominator. Right now the 5 has a denominator of 1. So in order to get 5 to have a denominator of 3, we would multiply the denominator by 3, which means multiplying the numerator by 3. Adding and subtracting fractions require common denominators. Multiplying does not. Am I done? No? No, but I'm close. So y equals 5 thirds x minus 5 thirds. Okay, we're going to end on a really fun one. Well, I don't know, at least it's really simple. How's that? Okay, here's the cool thing. This one talks about horizontal and vertical lines. So if you have a horizontal line, it's flat, right? If you have a horizontal line, then it is a constant height, right? It's like running on a flat surface. It never changes. The height never changes. It has the same y value the whole time. So horizontal lines are simply y equals a number. Vertical lines, they have no slope, that's true. And when we're looking at a vertical line, it's the x value that never changes, right? Always the same, like the side of a building. So x equals. So for your horizontal lines, if it is going to be passing through the point negative 2, negative 9, it has to be the equation y equals negative 9. And on your vertical lines, if it's going to be passing through the point negative 2, negative 9, it has to be x equals negative 2, because that is already the given x value that you have. You don't even have to draw the lines. I'm just using them as a visual. Okay? So we have our x equals, we have our y equals, and we're done.